Good morning. Today we are discussing on Gibbs energy of the reaction in the case of electrochemical cell. So, in a cell, what happens? The electrical work done in 1 second. Electrical work done in 1 second is equal to the electrode potential of the cell. The electrode potential multiplied by total charge passed. Okay, total charge passed in this reaction. Okay, electrode potential is E of cell. Okay, and total charge passed will be N into F. N is the number of electrons taking part in the reaction and F is Faraday. Now, what is Gibbs energy? Gibbs energy is the maximum work done. Okay, Gibbs energy is the maximum work done. So, in a galvanic cell, we can see the maximum work done is possible if charge passed is reversibly. If charge passed is reversibly. Okay. So, how can we write? This Gibbs energy can be represented as delta G of R. Okay. Gibbs energy of the reaction is delta G of R, which will be equal to E of cell into NF. By sign convention, since the energy is passed, the charge is passed reversibly, delta G, the value will be a negative value because the Gibbs energy is decreasing. In a galvanized cell, if the reversible work is done, means there is decrease in work done, the decrease in Gibbs energy. Because the charge is passed reversibly, the work done will be a reversible process. So, Gibbs energy is decreasing. That means the value will be a negative value. So, delta G of R will be equal to minus E of cell into NF, or delta G of R equal minus L NFE. Okay, this is the reaction. Now, next here E of cell, we know it's an electrode potential. E of cell is a intensive property. It's an intensive property because it never depends upon the quantity. What happens to NF? N changes depending upon different reactions. N changes. So, number of electrons taking part changes. So, NF is a extensive property. That means delta G depends upon N. So, delta G is an extensive property. Okay, is an extensive property. It's an extensive property. Now, consider reaction galvanic cell. Zinc. Okay, this is a reaction. Gives Zn2 plus Cu. Okay. So, in this case, 2 electrons are taking part. So, delta G of R will be equal to minus 2 Fe. But if we take 2 Zn, the reaction is 2 Zn. If the stoichiometry is changing, what happens? Okay, plus Cus. Stoichiometry changes. In this case, what happens? So, N gets converted into 4. Okay, so delta G will be equal to minus 4 Fe. So, depending upon the number N value, delta G changes. It's quantitative. Depends upon the quantity. So, delta G is an extensive property. Okay. Now, the relation is delta G of R is equal to minus NFE. Okay, this is the relation. Now, first case, if the concentration of the reaction species is unity, if concentration of reaction species
is unity. Then what happens? E of cell, this is E of cell, will be equal to E standard. Okay, this will be the case. That is, in a galvanized cell, the concentration of Zn2 plus by Cu2 plus. This is the concentration of the reaction species. This will be unity. So, E of cell will be equal to E standard of the cell. So, delta G, we can write it as minus NF E standard of the cell. Okay, so using this we can do the problem. We can calculate delta G of R if E standard of the cell is known. It is a fixed value, it is constant. So if it is known, we can easily calculate delta G of R. Now, if E standard will be equal to, is a unit, is negative value. If it is a negative value, what happens to delta G of R? It will be positive value. Delta G positive means it is a non-spontaneous process. Okay. The reaction is non-spontaneous. Now, next, if E0 of cell is positive, what happens? Delta G of R will be a negative value and it is spontaneous. Okay. And at equilibrium, delta G will be 0. Okay. Now, next, we can form a relation between delta G and Kc, the equilibrium constant. How can we find? At equilibrium, we know E standard will be 0. It is E of cell. E of cell will be 0 at equilibrium. So, from Nernst equation we got E standard of cell will be equal to minus RT by NF ln Kc. Okay. So, what will be delta G of R? Which will be equal to minus NF E standard. Okay. E0 of the cell. E0 of the cell is RT by NF ln Kc. Okay. So, this will be equal to minus RT ln Kc. This is another relation between delta G of R and Kc. So, we can calculate Kc if delta G of R is known. Okay. Now, what happens in the case of delta, in the case of spontaneous and non-spontaneous process for Kc and delta G? Okay. First case, in a non-spontaneous process, what happens? Non-spontaneous process, delta G is a positive value. Delta G is positive. Okay. If delta G is positive, from the Nernst equation we can see that Kc will be less than 1. Because Kc, the concentration of the product by reactant. So, reactant will be more. So, in such a case, the concentration of reactant is more means Kc will be less than 1. Okay. Next, spontaneous process, what happens? Spontaneous, delta G is a negative value. So, Kc will be greater than 1. Okay. Kc will be greater than 1 in a spontaneous process. And in the case of equilibrium, third case is equilibrium, delta G is equal to 0, Kc will be unity. Okay. This much about Gibbs energy of the reaction. Now, do some problems based on this.
Problem is, standard electrode potential for Daniell cell is 1.1 volt. Calculate Gibbs energy. Now, in a galvanized cell, what will be the reaction? Zn plus Cu2 plus gives Zn2 plus Cu. Okay. And E standard is given 1 point. Standard electrode potential is 1.1 volt. It is fixed. It is standard value. Now, what about delta G? Equal minus NF is standard cell. Okay. What about N? N is 2. F is 96487 into 1.1. So, what will be the value? minus 212.3 kilojoule mole inverse. So, this is the first problem. Now, next problem is second problem, the cell in which the following reaction, that is 2Fe3 plus 2I minus gives 2Fe2 plus I2. Standard electrode potential is given. Calculate standard Gibbs energy and equilibrium constant of the reaction. So, the reaction is this. Okay. So, delta G will be equal to minus NF is standard is equal to minus N is 2 into 96487. This is the Faraday's constant into 0.236. This will be equal to, the value is minus 45.54 kilojoule. Okay, this will be the value. So, we got Gibbs energy. Now, what will be equilibrium constant of the reaction? Log Kc will be equal to NFE of cell by 2.303 RT. This is the equation, because minus RT ln Kc. So, log Kc will be equal to NF E0 of cell by 2.303 RT. Substituting all these values, this is 2 into 96487 into 0.236 by 2.303 into 8.314 into 298. Okay. So, by substituting all these values, we got Kc 7.95. 9854. Now, what will be Kc antilog of that value? This is equal to 9.69 into 10 raised to 7. This will be Kc 9.69 into 10 raised to 7. Okay. This much about the Gibbs energy.